Hello students, today we will discuss a problem of IIT Advanced 2020. Given a function f r to r defined by fx equal to mod x into 1 x minus sin x. We have to check whether the function is 1 1 or on 2. This problem will provides important concepts of functions monotonicity graphical approach for efficient problem solving. This is a very important problem for in the sense of conception. So students, at first you should try at yourself. Then you can see the solution. Given a function, the function fx is defined in this way. Clearly, if we take f of minus x, then we can see that this function will become an odd function because modulus of minus x equal to mod x, and if we take minus 1 common, then we can see that this is an odd function. Okay, so if we sketch the graph for a part, then it will be symmetry about origin. This is the important property of an odd function. Okay, fx is an odd function. So if we draw the graph or study the nature of the graph for x greater than 0, then this will be symmetric about origin. So we will solve this problem considering x greater than 0. Then fx becomes x into x minus sin x. Clearly students, x is always strictly increasing. Then we have to study the behavior of this second part, that is x minus sin x. So just consider hx equal to x minus sin x, and we will see the nature of this second part, that is x minus sin x. Now if we take h dash x, then this will become 1 minus cos x, which is always greater equals to 0, and cos x will be 1 at exactly some points, some finite points in an interval, otherwise it will be always positive. So hx is an increasing function, To determine the graph of fx, we have to understand the nature of hx, because if hx is not strictly increasing, or it's somewhere it's increasing, somewhere constant, it will not be an one-on function. Okay, so we have to first clarify the matter that hx will be strictly increasing or not. As we can see that h dash x equal to 0 at some points, that is h dash x will be 0 when cos x equals to 1, that is when x equal to 2n pi. Except these points 2n pi, always h dash x is positive. So students, here another story begins from this part of this problem. Here is an important concept we have to understand very clearly, because this part may arise in different problems. So we have to understand this part very clearly. So the problem now arises that h dash x is not strictly greater than 0. It is equals to 0 at some points, that is x equal to 2n pi. Now students, using Lagrange's mean value theorem, we can see that in an interval, that is consider an interval alpha beta, okay, and in this interval uh, h dash x always positive, okay, except at some finite points, because n is a natural number. So if we consider any interval, the points in this form x equal to 2n pi, we will get just at a finite number of times, okay. So if we consider this interval alpha and beta, it just will be always positive except at some finite points. Then just we will use Lagrange's mean value theorem, and we can see that hx will be strictly increasing. This is very important part of this proof. Actually, we are going very deep analysis, so students, you have to look at this part very carefully. Just for simplicity of this proof, uh, just in this interval consider some points, uh, a1, a2, and so on an, where this function hx has a derivative 0, otherwise it is strictly positive, okay. So h dash a1 equals to h dash a2 equals dot dot h dash an equals to 0. Now consider this interval alpha comma a1. Clearly a1 is greater than alpha, okay. In this interval we are going to use Lagrange's mean value theorem, okay. Lagrange's mean value theorem. Then we can write h of a1 minus h of alpha by a1 minus alpha equals to h dash xi, where xi is a point between a1 and alpha. And as we already considered that they are only the points where h dash x equal to 0 is these points, a1, a2, an, and between alpha and a1 there is no points where the function has a derivative 0, and always derivative is positive. So this part is strictly greater than 0. So we can say h of a1 minus h of alpha strictly greater than 0. As a consequence, h of a1 greater than h of alpha, okay, and a1 greater than alpha, and we can see that h of a1 greater than h of alpha. Similarly, if we consider a1 comma a2, just use Lagrange's mean value theorem. Once again, we can see that h of a2 greater than h of a1, and continuing this process throughout this interval, we will have this function is strictly increasing. So uh, we have already concluded that hx will be strictly increasing, not only increasing, because it has a derivative 0 only at finite points. So hx is strictly increasing function. So now we can draw the graph of fx, that is mod x into x minus sin x, because we have already told that fx is an odd function, so whatever will be for x was positive, that will be symmetry about x is negative, and this part is similar for both the parts. So the graph will be look like this. As x is positive and the second part is strictly increasing as well as x. So the function will be look like this, and for the negative part it will be symmetry about origin, so this will be look like this. And students, uh, this term strictly increasing or strictly decreasing is very important, is or it has a very important geometrical significance to be a function 1 1, because if we consider a function, look at this thing, if we consider a function which is not strictly increasing, otherwise strictly decreasing, it will be look like this. And then if we draw any line parallel to the x-axis, it will genuinely cut this graph at more than 1 points. Here alpha 1 alpha 2, this is the two distinct points for this function fx, where f of alpha 1 is equal to f of alpha 2, because this is a line parallel to the, so the function is not 1 1 in that case. So uh, these terms strictly increasing or strictly decreasing is very has a very important holds or significance for a function to be 1 point. So as we can see that the function fx is strictly increasing. If we draw any line parallel to the x-axis, it will cut the graph at exactly uh, 1 points. Okay, at anywhere you can draw a line parallel to the x-axis, you will have exactly one cut. So clearly we can see that f is 1 1. F is 1 1. So one part is clear, that the function is 1 1. Now we will check whether this function is onto. Students, first look the codomain of this function, that is R. So if we uh, see the first part where x is greater than 0, then fx equal to x into x minus sin x. As a consequence of two strictly increasing function, this function is strictly increasing, and as x goes to infinity, fx also goes to infinity. So the range set for this uh, positive part, that is for this domain x greater than 0, range set will be 0 to infinity. As x tends, as x equal to 0, the function will be 0. Okay, and already we told you that fx is an odd function. Okay, that is f of minus x equal to minus fx. So the graph will be symmetry about origin, and the range set will be this portion, that is for the negative portion of this domain, the range set will be minus infinity to 0. So we can see that we can say for this negative part, we don't need to draw or calculate some things. Just using the property of odd function, we can say that the range for this negative part is minus infinity to 0, and as at x equal to 0, f of 0 0, and combining these all results and using intermediate mean value theorem, the range of fx will be r, so f is onto also. So our correct option is option C, both 1 1 and 2. Students, I think you understand this problem, and students, please, if you have any doubt on this lecture, you can comment. Okay, thank you.